what does it mean to balance a chemical equation? Well, remember Lavoisier's famous words, nothing is lost, nothing is created, everything is transformed. It means that nothing appears as if by magic, and that nothing disappears as if by magic. This is the law of the conservation of matter. Let's take the example of the reaction in which hydrochloric acid, HCl, decomposes into hydrogen gas, H2, and chlorine gas, Cl2. On the reactant side, we have one hydrogen atom, H, and one chlorine atom, Cl. These atoms rearrange, and on the product side, we have two hydrogen atoms, H, and two chlorine atoms, Cl. It's strange, isn't it? If nothing is lost, nothing is created, everything is transformed, where do the extra chlorine and hydrogen atoms come from? This is where the balancing of a chemical equation comes in. Balancing an equation evens out the number of atoms on each side, so that it's the same on the reactant and product sides. This is because the number of atoms of each type must be equal on both sides to reflect the law of conservation of matter. Okay, fine, but how do you balance an equation? Well, it's simple. All you have to do is indicate that two molecules of hydrochloric acid are reacting. We then have two hydrogen atoms and two chlorine atoms in total on the reactant side. The same is for the product side. The number 2 is called a stoichiometric coefficient. It indicates that the whole HCl molecule is present twice. There are several rules to follow when balancing a chemical equation. Rule number 1, the coefficient 1 is implied. It does not need to be written. Just like in math, 1x can be written as simply x. Rule number 2, as a general rule, coefficients should be whole numbers, not fractions. So avoid this and favor this. Rule number 3, the smallest possible integer is used for the coefficient. For example, avoid this and write this instead. Rule number 4 is the most important. Balancing a chemical equation is done using coefficients. You can never change the subscripts. Changing the subscripts changes the nature of the substance. So instead of this, we write this. Rule number 5, last but not least, when you finish balancing an equation, always go back and double check your answer. Now that we know the rules, let's do an example. There are several ways of balancing a chemical reaction. Here we will use the table method. In this reaction, nitrogen, N2, reacts with oxygen, O2, to form laughing gas, N2O. Yes, N2O is a gas that makes you laugh when you breathe it in. Using a table, we calculate the number of atoms of each type. Let's start with nitrogen. There are 2 nitrogen atoms in the N2 molecule, none in O2, and 2 in the N2O molecule. Next, let's count the number of oxygen atoms. There are no oxygen atoms in N2, 2 in O2, and only 1 in N2O. Based on the table, the number of nitrogen atoms is the same on the reactant side as on the product side, but this is not the case for the oxygen atoms. This means that the equation is not balanced and does not reflect the law of the conservation of matter. To have 2 oxygen atoms on the product side as well, we need 2 N2O molecules. By adding a coefficient of 2 before N2O, we now have 2 times 1, 2 oxygen atoms. However, we also affected the number of nitrogen atoms, which is now 4. We can add a coefficient of 2 in front of the N2 molecule to balance it all out. Time to check our work. The N2 molecule is present twice, which means that we have 4 nitrogen atoms. This is also the case for the 2 N2O molecules, which provide 4 nitrogen atoms as well. There are therefore the same number of nitrogen atoms on both the reactant and product sides. For oxygen, the O2 molecule has 2 oxygen atoms, and the 2 N2O molecules also provide 2 oxygen atoms in total. Thanks to the coefficients, the number of nitrogen atoms and the number of oxygen atoms are balanced on both sides of the reaction. That's it. The equation is balanced, which means that it respects the law of conservation of matter. There are other methods of balancing chemical equations. Whichever method you use, the important thing is to practice a lot so that balancing equations is no longer a mystery.